nice, and should put the seeds for our staples in the hand of foreigners. And then the next issue, of course, is this issue of safety. We have talked about it, and I don't think there's any argument, but I can say that it is saying that we should submit our precious God-given food sovereignty to the hands of such entities. As for adverse health effects following chronic ingestion of GMOs, this peer-reviewed research articles. I think I have this slide. Can you, of their paper, of their documents, they make the public slides. Sir? No, that's our article. Yeah, this is the paper. Malicious business solution. So it's well established, and nobody could counter, but they are from well peer-reviewed articles. Very, very well respected journals. Yeah, so the adverse effects are there. If I may chip this in, the issue with adverse effects is that, like Professor Ayori will tell us, if you just take something, I mean, there's some stuff, if you take it chronically and in large quantities, of course, it reasons that the adverse effect will be manifested more. So, like Mexico said, the audience in the population in the US, they don't eat those stuff as much as they eat in Mexico. But in Mexico, it's staple. In the US, it's just maybe I eat biscuits, I eat German biscuits. It's not clean. So it's German, I can just eat it on occasion. Forget it. Next month again, I eat it. But something I'm eating morning, there's look like that. I'm not going to I go to rice, I get to corn. It's the same thing. I drink pap. It's the same thing. It is really, really concerning. That's the point we just want to bring up. So the issue of loss of food sovereignty is clear. And the issue of adverse health effects, particularly when ingested in large quantities, chronically in your staples, it is like we just want to kill ourselves. And the issue of cancer, they're there, reproductive effects, they're all there. Every time we say we don't know where this is coming from, I believe, I want to say that we do know. And we should muster our courage to do something about it. So technology in China. If you read that paper, you will be embarrassed. Do you have it there? I think if you read that paper, you'll be embarrassed for Nigeria. I said to them, because it's so obvious that people were very lousy with they take us for granted. It is really, really shocking. Those people are trying to be polite, but they give all the points. So I encourage all of these academics. These are things that are, but it's very, it's published in the, I get the reference. So it's there. So the document, the author incredible shortness, characterizing the risk assessment exercise that was used to penalize GM cowpea in Nigeria. This damning report, to all intents and purposes, has been largely ignored by concerned authorities in Nigeria. I don't know what that can be on public view. and everybody pretends as if it does not exist. Nigeria was the first to do LP, so that's why these people were interested. And they saw the document. I see the document, I read it. We'll be sorry for yourself. How can we do things like this? It's as if those of us in the universities, we don't do anything. They say you don't hide anything from Nigerians. Go and publish it. And they won't read it. If you read that thing, I challenge you. I'm going to hear what my like what this is German. These are the pros and cons, which I agree also with. But these are the effects that we are pointing out. If you want to do this, after we do it properly, make appropriate corrections and provisions. Maybe if you cook it this way, if you do this, there will be a way out to mitigate the problems if you give enough time to do the study. But they are taking us for granted, not putting there, taking money. That is what is happening in our country. And we are trying to call our attention to this. In my previous something, we gave this, even, so let me just leave it like that. Because there are many issues with this. If you look at the certificate is not online, you can't find it. But when we saw it, it was for GM cutting. They just did cut and paste, and they forgot GM cutting there. So this is getting this appendage. So when we published it, they had to remove it. So it's no longer on their website. So that is clean version somewhere on international something, which I also. But the one on NBMA website is not there. You see it is missing. And the reason it's missing is that it mingled GM, it was talking of GM cowpea. And you can see inside the write-up, it was shoddy. The long and short is that they are taking us for granted. That's the way we conclude this survey. They continue to take us for granted as long as we are not interested, as long as we don't care too much. But if they know that we are going to interrogate what they are doing, then everyone will be serious and we do things properly. That is our point. So, and the regulation section 23(2)H says that appropriate labeling should be added. There's no labeling. So people should know what they are eating. In the US, they took almost 11 years to fight for the right to eat. And that right, that law will go into effect in June next year. And I believe that's one of the reasons why they are now focusing on us. If you want to eat GMO or something, whatever, please eat it, maybe due to cost or whatever. But we should be advised. And the law says that should be done. So our agencies should do that. It's as simple as that. Can't stop anybody from doing what they want. The authorities can do that. But we should follow what the groups say we should do. We therefore, number 4, we therefore hereby call on the relevant Nigerian authorities, especially the Nigeria Biosafety Management Agency, NBMA, and the National Agency for Food and Nutrition, to conduct or commission appropriate chronic toxicity testings that transparently ascertain the safety of GM foods, food products, before they are deployed for public consumption in Nigeria. It's as simple as that. Let's do the study. We have fed this to dogs, whatever, over 2 years, and these are the results. Then what is anybody's point to complain? If you have not done that, you ask the companies producing the stuff, they do their own testing, and they do that for what's called subchronic testing. And they say 90 days, the mice are okay. So go and give to Professor so they could commit people, studies in the universities. Now we are in the Department of Environment and Discovery. They could commission and give them this small grant. They do it, they peer review it. Then nobody asks what's anybody's complaint if that was done. But that is not being done. That is what should be done. So they should do that before deployment. It's interesting to note that in the ongoing issue of telomeres, NAFDAC said, the lady NAFDAC said they cannot vouch for the safety. But then the Minister of State called her to order. So you cannot do at variance with another agency. It's all in the news. Many of us had it. I don't think that's how to do science. We should be together. And then we move forward together. So we call on them to do this. So let me move to the second point, which is shorter, and the third point will be even shorter. This conference is actually talking about diversity, so that's why we spent more time on it. But this release addressing what we consider the three most important, in our opinion, topical issues. So one of them is what was spoken about. The next one is on the announced incorporation of malaria vaccine into routine childhood immunization schedule. Malaria vaccine in Nigeria, and its proposed incorporation into routine immunization schedule in the country. Number 2 point. We have nothing but commendation for the salutary efforts of scientists who doggedly and diligently labored to come up with the malaria vaccines. The idea for the malaria vaccine has lasted about 5 decades. And malaria vaccine is one of the toughest problems you can confront. It's not a virus. It has 2 hosts, the mosquito, human, going through stages. So it's terribly complicated. So that people who doggedly look for solution and come up with a vaccine. It's commendable, no matter the level of effectiveness of them. But our concerns with the product, however, have to do with the manner of its marketing and deployment, which is not consistent with the product description given by the developers. These concerns, published by us, maybe by reference, some 18 years ago, some 18 months ago, have obviously been totally ignored by the present action
Повреждениями нервов, вызванными ишемическим инсультом. Такому роду.
So I want to put this down. Having one year system protocol. Battery low. That's gone. And so it's passive analysis. Yes, that's what I So you love it.
Да. Развитие каких-то насыщенных жиров, красного мяса в большом количестве, ущерб, скажем, растительным белкам или тем же каким-то молоком растительным. Это те же растительные масла. Если человек будет переходить на в этом моменте использовать.
So, actually, the citation of our Bamide Adewale Salawu, 6 decades ago, attended St. Andrew Anglican Primary School, Odo Asoyin, via Ijebode Siwo, Ijebode, where he obtained a primary school leaving certificate in 1973. After his primary school, he attended Isoyin Grammar School, Isoyin via Ijebode, all in Ogun State, Nigeria.
Bamidele Adewale Salau obtained his HND from College of Technology, Ilesha, Ogun State in 1984 and obtained BSc, MSc at the University of Ibadan, 1992 and 1995, respectively. He obtained a PhD in biochemistry in 2011 at Olabisi Onabanjo University and later Bachelor of Theology at Life Seminary in Ikorodu. Obtained diploma in nutrigenomics from the Institute in 2020 for distant education.
The organizers of this program and all my distinguished professors and elders here, my fellows. I'm still a student, that's why I would say that I'm fellow students, and all other protocols duly observed. Just a little bit correction about the School of Health Technology. It's not in the it's in the same States. Thank you. I'm here to present a keynote speech on this very conference on bioengineering and biodiversity for sustainable development, the food, health, and environment nexus. When I received this invitation, like my friend Professor Joe told me that, well, I can adjust it a little bit to suit where I'm going to talk about. And when we look at the current things in the nation, especially when it comes to issue of food, health, and environment, there was a little bit adjustment, which is bioengineering and biodiversity for sustainable development, the food, health, and environment nexus, which means that how to enhance bioengineering and biodiversity for sustainable development, looking at the food, health, and environment connection. I'll start by a way of introduction and then definition of some terms so that we can have a full understanding of what we are discussing today. First and foremost, let's look at the outline which I'm going to present my discussion on. One, we talk about the introduction, which will talk about the definition and overview, contextual relevance, the role of bioengineering, and the role of the medicine, that is health, food, and environment. And also we look at the biodiversity, how it can help, and also how we can connect both together for the sustainable development. Permission me to mention that what we are practicing in Nigeria today is not really sustainable development. Because when we talk about sustainable development, it means that trying to make sure that we fulfill our own need, whether economically, health-wise, and other, without degradation of the environment or interfering with the future generation. But unfortunately, the Nigerian today is that we are eating tomorrow, today. And that is why even our government could borrow and borrow for the next 40 or 50 years, we won't be able to pay. And probably the reason for all this Japa syndrome we are seeing. So living with the old or the relatively old to pay the debt, the young one are living on the basis. So let's leave that aside. Bioengineering. The term bioengineering was first coined in English by a British biochemist and biophysicist William H.G. Westholm in 1954, referring to the application of biological principles and techniques to develop technologies and solutions that addresses various challenges in medicine, agriculture, and the environment. It encompasses genetic engineering, synthetic biology, tissue engineering, and bioprocessing, aiming to improve human life and natural world. Whereas biodiversity, on the other hand, describes the variety of life on Earth across different species, ecosystems, and genetic resources. Biodiversity is essential for ecosystem health, providing numerous services such as pollination, water purification, and disease. Together, bioengineering and biodiversity form a critical intersection in the pursuit of sustainable development, a model of progress that meets current needs without compromising the ability of future generations to meet their own. Sustainable development is closely tied to three major dimensions: food security, human health, and environmental preservation. Each of these aspects depend on healthy ecosystem and innovative technologies to sustain life and enhance human well-being. Sustainable development therefore seeks to balance economic growth and environmental stewardship and social inclusion. Thus, bioengineering plays a vital role by offering novel methods to solve complex problems that affect all three dimensions. For instance, bioengineering can provide food solutions for a growing population through genetically modified crops, address health concerns with personalized medicine, and support environmental protection by restoring damaged ecosystems. Meanwhile, biodiversity underpins this process by ensuring ecosystem resilience, adaptability, productivity, restoration, and conservation. Contextual relevance. The global challenges faced today highlight the urgent need for integrated approach that connect food, health, and the environment. Rapid climate change, disrupting weather patterns, leading to more frequent extreme weather events such as drought and floods, threatening food production and biodiversity. The global population projected to reach nearly 10 billion by 2050, further exacerbated the demand for food, water, and resources. The population growth places immense pressure on natural ecosystem, leading to environmental degradation, such as deforestation, soil depletion, and loss of species diversity. With this, it is clear that from the way the population is growing on, according to United Nations, say by 2050 is going to reach 20 billion. And the manner and the system of our agricultural practices, it means that if we don't evolve a better way, it's sure that we might not be able to feed ourselves by the time the population of the world reach about 10 billion. We should place so much pressure not only on the environment in terms of nutrients required for plants and other, but also means that the degradation of the environment is imminent. And so for this, the need for evolution of a better way of food production, maintaining environment and health. There comes the bioengineering. Food security is a growing concern, particularly in the region already vulnerable to climate change. Traditional agricultural methods often struggle to keep pace with rising demand while maintaining ecological balance. According to the Food and Agricultural Organization, around 2 billion people globally do not have regular access to safe, nutritious, and sufficient food. Without innovation in food production and distribution, such as those offered by bioengineering, it will be challenging to meet these needs sustainably. The decline in biodiversity due to human activities also poses a significant threat to both health and environmental integrity. For example, the loss of natural habitat contributes to the spread of zoonotic diseases that can transmit from animals to humans, as seen with pandemics like COVID-19. Maintaining biodiversity helps offer ecosystem against such destruction and promote ecosystem service essential for human health, such as clean air, water, and nutrition. In essence, even as much as we are involving new methods, especially in bioengineering, to make sure that we produce more food, we should also couple it with biodiversity, by which we try to maintain our environment, by which we try to maintain the integrity so that there will not be disruption in ecosystem habitat, so that will lead to many disease conditions, such as we witness in most of these zoonotic diseases. By the time their own environment is being disrupted and disturbed, it means that there will be intrusion and fluctuation of flow into our own environment, thereby leading to the spread of diseases, such as zoonotic diseases have been witnessed in COVID-19. Focusing on this connection. Okay, thank you. In this context, bioengineering emerged as a powerful tool for addressing these interlinked challenges by leveraging cutting-edge techniques such as genetic modification, synthetic biology, and bioprocess engineering. Bioengineering can enhance biodiversity and create sustainable solutions across the food, health, and environment nexus. For instance, bioengineered crops can be designed to be more resilient to climate stress, reduction in the impact of environmental changes on food production. Meanwhile, biotechnological advancement in healthcare, such as gene therapy or biofortification of crops with essential nutrients, can address malnutrition and improve public health outcomes. Focusing on the connection between bioengineering and biodiversity, a path toward a more sustainable and resilient future can be charted. Thus, intersection hold the potential to solve critical challenges with respecting the delicate balance of ecosystem that sustain life on Earth. Now, coming to the role of bioengineering. in food security. Well, I'm sure that we've all spoken much, I've heard much about issues of food, especially when it comes to bioengineered food, especially this issue of GMO. So I'm going to really deal a little bit on this, especially what is pros and cons. And so that is why we need to maintain very good biodiversity to make sure that there's a balance between the bioengineering and biodiversity in area of our food, in area of environment, and in area of genetic modification of crops. One of the most significant contributions of bioengineering to food security is development of genetically modified organisms, GMOs, that enhances quantity and improving quality. GMO have transformed agriculture by enabling crops to be more resistant to pests, disease, and environmental stresses, such as drought, salinity. This innovation helps enhance the crop yield, ensuring a more stable food supply from a growing global population. For instance, BT crops, which contain genes from Bacillus thuringiensis, produces protein toxic to certain insects, pests, reducing the need for chemical pesticide. This is not only protect the environment, but also cost for farmers. Yes, the Bible says in the beginning, it was not so. The purpose and the reason for most of this GMO food, if it is coming from scientific honesty, ought not to be what is it today. Actually, one of those crops that is being genetically modified is the maize that they brought to Nigeria now, and which we are trying to establish. Other crops like soya beans, like cotton, and we could say that we are taking tea in Nigeria, put like and sinker without asking questions. I think this is where the problem is, and the mode in which it's being presented to us. Because we know even some countries, not only that you cannot cultivate GMO foods, you cannot even, they don't allow it to be sold to their populace, to their own citizens. Because most people could not really know, or we cannot say yes, this is likely to be the outcome. This is likely to be the outcome. Effect of this most of this GMO. Effect of this GMO. Because science is many times present something that looks like a solution, but at the end of the day, there's going to be a problem at the end. So that is why some people are being cautious, especially when it comes to GMO food. I remember many years ago in early 60s, when the thalidomide, a drug, was thalidomide was discovered. It was used to solve a lot of problems, especially morning sickness for pregnant women, so that they don't have problems when they take it. They can just go all this morning sickness that accomplish first trimester pregnancy. So, was solved in a way, and it was a good period. But not long enough, they now discovered that thalidomide is teratogenic and producing a cause of a lot of deformities in people. And probably one of the reasons why some countries insisted that they don't want this GMO food. There were a lot of researches, there's a kind of level of scientific dishonesty because they are trying to cover a lot of those researches that have shown that most of these things will be toxic. So, and as a result, some of these countries insisted that as for now, they are being cautious. But let's look the good aspect of it. If it is practiced in a normal way, it ought to be. Unfortunately, science today has been politicized. Science today, there's a lot of dishonesty in it. Science today has been in a way can be more tends toward economics rather than to real science or to be. So let's first of all look at the goodness, the good aspect of it, before we now go to where we need to take caution. The insecticide protein produced by Bacillus thuringiensis, particularly that is crystal and cytolytic protein, provides a powerful and targeted approach to pest control. Protein act by binding to specific receptors. Don't let me go too much of the biochemistry of this. The essence of this bacillus thuringiensis is that it's a bacteria that when its gene is being inserted into the plant, it will produce a specific insecticide to some of the pests to our plants, such as the maize, the stem borers, maize, and like soya beans and cotton. The essence of it is that those toxic or those toxic protein is specific for those pests. So naturally, it's supposed not to actually affect human being or other insects, so as to not to disturb the ecological balance. The basis in most of those designs is that to look at a particular pathway that is present in our pest of interest, and then design drugs to make sure that it will only attack that part. For instance, you use your video seed. They normally kill rats, but they will not kill human being. Because that particular pathway that is not human being. So this one of how this is how those things happen. So it has been shown that bacterial species is a bacteria even produce such natural pesticide, insecticide that will kill most of these pests and insects that affect maize, soya beans, cotton. And so they are able to get that gene and insert it into the plant. So as the plant is producing and its normal growth, it will now be producing that insecticide. So those pests will not be able to affect those plants. Good enough. That's all it's supposed to be. But we'll now see some of those downsides as we go on. So another groundbreaking advancement is the use of CRISPR-Cas9 technology, a prized gene editing tool that allows for modification of specific genes in crops to improve their resilience and nutritional value. For example, drought-tolerant varieties of wheat rice, which are staples for billion people worldwide. Such innovation are crucial, more or less an antidote to climate change, thereby increasingly affect crop productivity. Moreover, bioengineering enables biofortification of crops, where essential nutrients are added to staple food to address malnutrition. A prime example is golden rice, which has been genetically engineered to produce a beta-carotene, a precursor of vitamin A. This innovation aims to reduce vitamin A deficiency, which affects millions of children globally, particularly in developing countries, leading to blindness and even death. Yes. Gene editing and especially using Cas9 technology is one of the areas that we really know that bioengineering has really helped with food production. For instance, it has helped like to be able to improve the genes of those plants that will be able to survive on less water, especially in drought areas where there is insufficiency of water. They are able to do this in wheat, in rice, and so on. And aside from that, biofortification. When Professor Ojo was talking about a particular cassava that was engineered those days and they were trying to plant it here, and the thing was not really growing. Actually, well, I think the technology has grown a little bit more. But unfortunately, like I said, the science is still evolving. There are a lot of issues when it comes to this engineering of such plants. For instance, the cassava will not be able to grow here because they discovered that it does not produce cyanide. And cyanide is one of the toxic principles that we want to remove from cassava so that everybody can eat it without such toxic principles. But unfortunately, most of these plants that we think that they have this toxic principle, whether cyanide, whether solanine in potato, whether ricin in whatever, all they are being produced by this plant true evolutionary trend for the survival of this plant. So in which we call those things, we call them secondary metabolites. They are not really primary metabolites. But this plant, they produce those things according to their environment so that they can survive. For instance, most of the legumes, they produce estrogen-like materials in which as a secondary metabolite in which they can survive. Why are they doing that? Nature is so wise, so that those things will continue their own generation, even those plants. Because take, for instance, legumes that are very nutritious and very proteinaceous for even animals. If they don't design a kind of survival mechanism, it means that most of those plants will just be predated by prey and they will finish them off. But when a particular set of animals goes to this particular set of plants, maybe these legumes, and because that thing contains estrogen-like material, which more or less act like not abortifacient now, like what we use to prevent pregnancy, what do you call contraceptives. Those things act like contraceptives. So those animals that are eating them will not be able to produce. Instead of exterminating that plant, that animal will be aggregating or exterminating themselves. So that is the way nature is being designed. So you don't continue eating a particular kind of food all the time, so that food will not just disappear from the planet, from the surface of the planet. So it has developed a kind of mechanism in which that poison is there, but the time you eat too much of it, it's going to affect you. Thank God the man Prof here from environmental toxicology will tell us more about that. So also here, the golden rice. In fact, there was time there, I think golden cassava was also produced, in which all what they do is that find a particular gene that is responsible for production of beta carotene. And beta carotene is a provitamin, that is to say, is the basic that when you eat it, you get your vitamin from it in a particular pathway in which we can degrade it and produce vitamin A. Beta carotene is not a vitamin A, but it's a vitamin A. So they now try to get this gene, insert it into the plant. So as the plant is growing normally, the gene also will be producing beta carotene. So you get your yellow cassava or you get your golden rice. These are all goodies that bioengineering or biotechnology supposed to do. But we will see where the problem is now coming from now. So additionally, bioengineering has helped in the production of functional foods, in which are being developed to address diseases related to diet, such as diabetes, cardiovascular diseases. These foods contain ingredients that provide health benefits beyond basic nutrition, such as bioactive compounds that can help regulate blood sugar, levels of lower cholesterol, by making nutritious food more accessible and affordable. Bioengineering can help reduce the incidence of diet-related diseases, especially in the underserved communities. Yes, like I said, aside from the production of, in terms of quantity, in terms of quality, in terms of functional food are those food that, aside from serving nutritional needs, they are able to serve more or less medical needs in a way. That is to say, the types of bioactive compounds, such as nutraceuticals, that will be able to work like drugs. For instance, in our laboratory, we have been working on some of these bioactive compounds that will be able to lower or stem the tide of cardiovascular diseases. And we are able to be able to isolate some compound. And what is our interest? If we're able to get this compound, be able to characterize it, get the gene, we involve the agriculturalists, especially those biotechnologies. Is it possible to help us use a way of getting this gene into our common food we normally eat? And then as a result, do gene boosting, so that those food, maybe our vegetable, as they now we normally have their vegetables, they will produce those compounds naturally. For instance, high level of like stigmasterol has been shown to be able to lower cardiovascular problem, hypertension, and so on and so forth. And some plants have this masterol, which look just like cholesterol. So I want to be able to get it and be able to characterize it, get the normal gene, and then insert it, then plant will produce so much of this masterol. So when you eat it, instead of buying drugs and this, it will help you to lower, stem down this issue. So these are the kind of things about engineering supposed to be looking at in the beginning, unlike what is happening now. So, and by the time you are able to do that, it means that you will solve a lot of problems with this. Sustainable agriculture. In the face of growing environmental concern, the engineering offers sustainable agricultural practices that reduce dependence on harmful chemicals such as fertilizer and pesticide. Biotechnological advances allow for creation of crops that can fix nitrogen from the atmosphere, such as rice and cotton, to form symbiotic relationship with nitrogen-fixing bacteria, enhancing their ability to access and utilize atmospheric nitrogen, similar to legumes, reducing the need for synthetic nitrogen fertilizer, which contribute to greenhouse gas emission and water contamination. So the essence of our engineering is to enhance sustainable agriculture. And one of the ways is like we have just said now. We know legumes from their natural way, they are able to fix nitrogen, to form nitrates in the form of kind of fertilizers. And by the time you are able to get these other our staple foods to be able to secure such a gene that allows legumes to do such, and then insert it, it means that your rice will be fixing nitrogen. You will not need so much of NPK fertilizer. So naturally, it will produce its own fertilizer. Let's be aware that we have been trying to produce the one that will produce pesticide. We are not trying the one that will produce fertilizer. Even we go further of enhancing search for biodiversity and sustainable development to make sure that they have a kind of enhanced root that can penetrate deeper into the soil and able to accumulate and collect nutrients, so and to improve soil health. This is what bioengineering is supposed to be. Bioengineering also improves soil health, which is essential for sustainable agriculture. For example, genetically engineered plants such as soybeans with enhanced root system can capture nutrients for more efficiently, reducing the need for chemical inputs and improving soil structure. This prevents soil erosion and helps maintain soil biodiversity, which is critically long for agriculture. In addition, vertical farming and lab-grown meat are bioengineered solutions that offer alternative approach to traditional farming. Vertical farming uses stacked layers in controlled environment to grow crop year-round, requiring less land and water. Lab-grown meat, that is culture of cultivated meat, on the other hand, is produced by culturing animal cells, providing more sustainable and ethical source of protein without environmental cost. Or traditional livestock farming also addresses concerns around animal welfare and food security. This innovation represents a significant step toward sustainable production in urban and rural regions with limited agricultural land. Yes, in the vertical farming, in which most of it is the variance of it is always our stack farming and whatever, in which with lesser land, with little land, little water, we can do our farming. But when it comes to this lab-grown meat, yes, it arises. As you know, there are some people that believe that, well, animals also should have their own welfare. The way we take them and slaughter them and kill them, they have their own life. And as a result, can we develop a better method in which we not be killing animals? So one of the reasons is that this lab-grown meat, in which with the infiltrating tissue cells, grow it, feed it with nutrients, and then we'll grow more muscle and more muscle. You can use it maybe for chicken, you can use it for goat, whatever. But the unfortunate aspect of it is that science always outsteps their boundaries. I was reading a particular, that thing went viral, in which this lab-grown meat, even they were trying to portion human flesh. And so people were even saying, it is a very good one, it is a sweet one. You can see some of the ethical issues that it arises. So give a man if you want to take a mind. So these are some of the problems. Conservation of plant genetic diversity. Preserving genetic diversity in crop is essential for ensuring food security, particularly in the face of climate change. Diverse crop varieties are more resilient to disease, pests, and environmental disease, which can threaten food production. Bioengineering plays a crucial role preserving this diversity by enabling development of climate-resilient crops that can withstand extreme weather conditions. For example, engineered heat-tolerant wheat varieties have been developed to cope with rising temperature. Now, so these are what bioengineering is supposed to be doing in food, or either bioengineering about technology or synthetic biology, whatever way we want to put it. So, in the area of food. In the area of medicine, likewise, bioengineering ought to help and improve our medical condition, health condition. One of it is the recombinant DNA technology, which is a form of genetic engineering. And one of those things that bioengineering is trying to solve is most of the diseases that appear incurable or with problems in the past, they are now helping us to really solve it. For instance, the recombinant DNA technology as a form of bioengineering is used in production of insulin, especially for those people that have diabetes. In the time past, people that have diabetes, the problem is that they have, especially type 1 diabetes, which is insulin-dependent diabetes. The problem is that they have to go and harvest the insulin from cow or from pigs, which are very close to that of human being. And they have to preserve it and purify it and normally inject it into those people having it. But with the understanding of bioengineering, genetic engineering, it is not possible, having known the gene for that. What they just do is that cut the gene, insert it to bacteria, and the bacteria into its plasmid. Bacteria will now start producing insulin. And that's what they have been doing for the past. And so that's how insulin is being produced. And they have been using it in forms of other biomolecules that are of medical interest. So as a result, it has solved the problem and still solving it. So people with diabetes, they can get it at a cheaper form, not that they will be killing many cows or many pigs. Unfortunately, by the time they are using pigs or cows, the Jews will not take pigs. The Muslims will not take pigs. And what they are not ready to take by mouth, they won't want to come and inject into them. So it has helped to solve a lot of problems. So this is what bioengineering is supposed to be doing in the medical area. Production of insulin. Also, human growth hormone, which is one of those things that is being produced using recombinant DNA, which is now used to solve a lot of problems, especially in patients with growth hormone deficiency that are linked to several and other production of this human growth hormone, which the job is just being done by bacteria, E. coli, help us do this job and produce it. The method is basically simple. That is to say, with the Krebs method of understanding the exact gene that is responsible for the production of that particular compound or proteins. What it just needs to do, call that exact gene by the restriction enzymes, and then insert into a plasmid. A plasmid is circular DNA in bacteria. And then when that bacteria is doing this normal job, it will just be producing that particular molecules or active compound of interest. So that has been used in human growth hormone, erythropoietin, and even more monoclonal antibodies, in which, and even interferons. Also, we know that genetic engineering or biotech engineering also has helped in the area of recombinant vaccines. You know, the normal way of producing vaccine in the past is either you get those viruses or whatever those microbes, you get them attenuated. That is, okay, you got them weakened, and then you will be able to now produce. So when you inject it, it will now produce a kind of reaction or antibody in that person. But presently, with it, understanding the microbe cell, what is still responsible for it to produce for its antigenicity? It is that we now try to get and be able to inject it, and the body will now produce. So it will not be the entire microbes or the attenuated one. And that is what the technology that we use in this COVID vaccine. Let me now quickly, because the time is going, let me quickly go to So also it's useful in gene therapy, it's useful in bioengineering for public health, especially when it comes to bioremediation, when it comes to phytoremediation. All these are, I think it is in this lecture note. But let me quickly talk about some of these problems that with these issues of GMOs. Now, one of the problems with the GMOs is that it's supposed to really solve our problems, but if care is not taken, it's going to create more. Now, challenges and future direction. Despite its success, bioengineering is not without challenges in every area of its usefulness. It has always posed one problem or the other, making it a double-edged sword in many areas of application. One, the food security. While engineering has solved many problems of food security, it has downside. For instance, one of the methods used in GMO food in order for the company to recoup the cost is terminator, known as genetic use restriction technology. Terminator technology refers to type of genetic modification designed to render the seed produced by genetically modified plants sterile. The goal is to prevent farmers from saving and replanting seed from their crops, requiring them to purchase new seed each session. While this technology was developed to protect the intellectual properties right of the seed company and control the spread of the GMO traits into wild or non-GMO population, it has sparked widespread controversy, particularly among farmers, environmentalists, and food security advocates. Below are the key demerits. Below are the key demerits. One, impact on farmer livelihoods. One of the most widely voiced concerns about terminator technology is its impact on the traditional practice of farmers, especially small-scale farmers in developing countries. Loss of seed sovereignty. For centuries, the farmers have saved and replanted seed are a practice that ensure their independence, lower costs, and allow them to adapt to local conditions. Terminator technology disrupts this tradition by forcing farmers to buy new seed each session. This particularly harms small-scale farmers who rely on saving seed from one harvest to the next. The financial burden of purchasing seed every year can be overwhelming for low-income farmers. 3, dependency on multinational corporations. It means that until they get to that multinational corporation, there is nobody that can get seed to plant. 4, threat to biodiversity. Biodiversity in agriculture is crucial for food security, resilience to climate change, and pest control. The use of terminator seed possess several risks to biodiversity. 5, erosion of genetic diversity. When farmers are no longer able to save seed, they lose the ability to select and breed crops that are well suited to their specific local conditions. 7, risk of wild plant species. Although terminator technology is designed to prevent the spread of GMO traits to other plants, no system is perfect. There is concern that if the sterility gene unintentionally transferred to wild or non-GMO crops through cross pollination. That is to say, if I'm planting the GMO maize now, and somebody is planting the wild pigs over there. So the possibility of pollination, cross-breeding is happening. So it means that it's still its own crops that naturally will can save the seed for next season will become sterile also. So these are some of the problems with this GMO seed. 5, exploitation of vulnerable communities. 6, food sovereignty. It means that our food sovereignty is being taken over. It means they are the one that will be controlling. The impact on food security, increasing cost for our farming. I think I was reading maybe we're part of country in East Africa. You see, they started introducing this GMO food today. Little by little, they make sure that they don't have their own normal or wild thing. So at the end of the day, they become poorer. Like the example given by Professor Ojo, when they started, they were buying at 7 rupees. But now, immediately they know that they have eliminated all the wild one or your own natural one, they can now raise the price. It's just like when they trick us that they stop using kerosene, stop using firewood because of deforestation. Come and use gas. We started buying at 200 or 150 naira. Now you know how much it starts. So then we have many people, they don't even know how to, most of these children are not even operate stove. Or even make firewood. So we are being forced to continue. So probably the GMO will lead to that. Environmental concern. Why the primary goal of terminator technology is to prevent the spread of GMO, trace of non-GMO, as I've said before. Then gene flow to non-target species, then reduction in agricultural biodiversity. So as a result, all these has the problem from economical, from agricultural and the GMO. Then more than this is this issue of cancer, which a lot has been writing on it. Though most of the public media has been trying to, or most of the public outlets in science have been trying to deny this. One of those things they said that, for instance, when you use a GMO food, like the one like BT comes, you will now need to use a herbicide. And most of the herbicide they use is glyphosate. And glyphosate, it means they will use it in higher level. They normally use it at higher level on most of these plants. And they said that it is because of high level of this glyphosate that is carcinogenic. So that it is not GMO food that is actually carcinogenic. But whichever way, GMO food will allow for higher use of glyphosate, which is a herbicide. And as a result, it directly or indirectly leading to carcinogenic situation and many cancers. And that's why many countries are now even banning the food. So with this, let me quickly conclude. In summary, bioengineering holds immense potential to address some of the most pressing global challenges in food, health and environment, sustainability. By harnessing the power of genetic modification, synthetic biology, and biotechnology, we can enhance crop yield, improve human nutrition, and restore ecosystems that have been damaged by human activity. Biodiversity, meanwhile, serves as the foundation of sustainable development, providing the resilience and adaptability that ecosystems need to drive in the changing world. By integrating bioengineering with efforts to conserve and promote biodiversity, we can create solutions that are not only innovative but also sustainable in the long term. The intersection of this field offers a powerful way to ensure that we meet the needs of the present without compromising the ability of future generations to meet their own needs. Looking ahead, it's clear that continued research and innovation in bioengineering are essential for achieving global sustainability goals. Future development in genetic modification and biotechnology will likely provide more tools for enhancing food production, improving human health, and protecting the environment. However, it is equally important to prioritize ethical, sustainable, and inclusive approach as a way forward to ensure that engineering contributes to a balanced food health environment nexus. It is vital to engage diverse stakeholders, including indigenous community, policymakers, and the private sectors. This will help to ensure that bioengineering solutions respect local culture, protect ecosystems, and are accessible to all in the way bioengineering can fulfill its promise, helping to create a more sustainable, equitable, and resilient world. Thank you for listening. For your wonderful lecture. Yes.
Okay, thank you. We have we skip a little of our program. I will come back to that later. This lecture have a form of interaction, question and answer. We have listened to a very wonderful lecture from our distinguished professor. Maybe we have seen one or two things or we want to get clarification. It's time for us to do that now. We can ask questions and maybe and also do a form of interaction so that it will not just be one-way traffic. We will also have. Thank you, sir. Thank you, sir.
Thank you, distinguished professor, for the information and enlightenment. I really appreciate that, sir. So, what I just been said to me is that we should have a form of rapporteur who will give us summary of the lecture, and our daddy has volunteered to do that for us. So please let's give him a round of applause. Thank you, sir. Thank you. Professor Salam, I really appreciate you. You have done wonderfully well. Very good sound business practice. Professor Joe, hear this. I'm glad Life Science Foundation is not condemning biotechnology, it's not condemning GMO or whatever. Caution is what is important. And that is what our professor has emphasized. It is, if they say you are a fool and you act like a fool, who is to blame? Nigeria is, and people at biotechnology and biosafety are the idiots. Yeah. Now, if I were there, I'm just saying, I'm an old man. If I were there, I would say, okay, you have developed this GMO. Give it to me. I will establish a testing field for 2 years. Give each university, maybe 34 universities, the sample, go out and test. After 2 years, continuous, you can then come back and give me the results. If it is okay, then I say it is acceptable. For universities, you cannot bribe all of them. Therefore, it is important to really have the biosafety agency to start doing their job, not just collect money. I mean, I know dollars can be tempting, especially when it is now 1,600 or 1,700 naira to the dollar. It can be very tempting, but let them also do their job, not for us, but for their children, for their children's children. It's important. I won't repeat all that Professor Sadawa said. In fact, he has gone down the lane. All the important things. For instance, he said some of these secondary metabolites are possibly defensive in nature. We did one very simple experiment here in Israel, just to buttress his points. We took the sorghum leaf, it contains cyanide. We said, okay, if you take the leaf, is this long and at times longer? What the animal will get at is the tip of that leaf first. So we look at the level of cyanide, which is chlorine, in the sectors. We cut it into 3, 4, 5 pieces, and we found out that the highest concentration of chlorine is at the tip of the leaf, where the animals would get to us. So that is a very simple way of saying it also has defensive mechanism. Now, we cannot but have a GMO. Let us not deceive ourselves. It is the way to go. Not only in agriculture, but also in health and in environment. Our Niger Delta is polluted. How are we going to solve that problem? It is only by GMO. We will use microorganisms that can break down the hydrocarbon. Prof also told me about the GMO that will act as pesticide. Now, what were we doing before now? We will spray it. We will spray with pesticide. What are pesticides? Chemicals, phosphates, sulfur, and this will be absorbed with the heavy metals. So we are either taking one, leaving the other, or whatever. In which case, whatever we do, there are bound to be problems, but we will take the lesser of the evils. The lesser of the evils. I agree completely that, and Prof has also said it, that whatever it is should be labeled. We should have a choice. You can have organic food, you can have fertilizer, produce food, but let that be. If I have 10,000 naira to feed myself for 1 month, I cannot afford to go organic. But I will try to die. What is the GMO? And I think, okay, it's cheaper. Let's go for this. Now, what do we do? The government should be able to differentiate and say, okay, if you are planting GMO, the farmers, the large-scale farmers should concentrate on GMO. There are other peasant farmers produce organic for us, and whoever wants can now go in and buy whatever he wants. You see, in the 80s, finally, sir, I'm sorry if I'm taking so much of your time. In the 80s, in the Czech Republic, there was so much famine, people were dying. People were dying. And they said, okay, they were taking the bark of trees, neem tree, of trees. They were taking the bark, they would pound it and sieve it and use it to cook amala or whatever. They would say, when they were told, this thing is poisonous, they said, yes, we know it is poisonous, but it is better we eat it and die rather than die of empty stomach. So, if you are saying, don't take GMO, I mean, the alternative might be worse than people taking it. Finally, I'm sorry. I said finally. Finally. You see, Professor Banade and I were on a 20-year project trying to develop acacia food. Because acacia is one of the hardy plants that can grow in the Sahel. And we said, okay, it was a 20-year project. And after 20 years, we went to Australia to celebrate 20 years of research. And I had the honors of telling them what we have done over a 20-year period. There was this gentleman, a young man, who said, yes, there's farming in East Africa. Let us introduce acacia to them. There are acacia plants in that country, but we are never tilted it. And he said, we can just ask them to start eating. Without testing, without doing any work, any research, I convinced the people not to go that way. Fortunately, the Tanzanian government, I think, and Kenya government instituted the research, and lo and behold, their acacia feed all the animals. And they said, hey, Adewusi said this, cautioned us, if they have not taken it, it would have been disastrous. They will say, those Oyibo people wanted to kill us. Oyibo people never want to kill us. We are the simple ones. And we should at least make it proper, make it essential for our agencies to do the work that they are paid to do. Thank you.
Let's have a very big round of applause for our family. Once a teacher is always a teacher, I'm very proud of you one. Thank you, sir.
So we can go for you. Thank you, Chairman, for contribution. We impressed men like them, said we give them the first to ask questions. Then so it will be Dr. Hill, before even then, Dr. Akiwumi, the Southwest President of Government Head of SAS, which is part of our committee for FOA plans. He has a seminar. He has to be. He just wants to bring people also to this meeting. And please, while this is coming, I want to apologize. We ought by not have given the everybody class, and the plaque is not yet there. This is for the children, the school children. So please accept solutions. We get them. And I think we can be serving the question, please. Thank you.
The chairperson, sir, all of that protocol till observed. I suppose not to talk when my guest talked. Let us allow, was my 9 years senior in the college, and he has presented very well. What's expected of me is to thank him. Prof, thank you very much. However, he has actually touched some area of interest, particularly to him and myself. He has talked about environment. We believe in environment that you all belong to us. Those of us in the environment, because environment has a lot of influence on human and other factors. Because environment influences almost all we do. And the theory of environmental determinism has made us know that all you do is determined by environment. You can query me, I will explain further. Oga has also talked about human health, especially, though he touched the area of animal health. We believe that the precious asset of a man is good health. Remove good health from man, it is no man. Thank you very much in that area, because though, like Prof said, Oga touched some areas about the implications of GMO food. There are a lot of implications. But thank you for dodging it because of this gathering. However, there are implications, there are challenges that are inimical, that are prejudicial to our health. Or if you go through that slides, that lecture, you can pick some that are very good for you there. Also, guys talked about food. We all know what food is. Let me refer you to section 32 of Public Health Law, still subsisting in all states of Nigeria. Go and look at it very well. Go and look at it very well. That your food is your health. Like Prof said, some people said, let us eat evil and die. Don't eat and die, we will not die immediately. That's why we believe that prevention is always cheaper, better, safer than cure, because we have medical doctors here. Treatment may fail, drug may fail. Don't believe that let me eat and die. You may eat and be in between, incapacitated. And what life is that? It is no life. So once again, I want to appreciate Professor Allah. I'm not expecting less, with due respect, from his foundation, and has done very well. As from the inception of the lecture to the end, we appreciate you. Thank you very much, Mr. Chairman. We appreciate you. Professor Ujo alighted me from my car because I was rushing to Ibadan for the lecture. Thank you once again, and I wish all of us happy celebrations. Thank you.
Thank you very much, Dr. Kimini. Thank you very much, Chairman Sir, and Professor Salau. I think that was just too much. You touched everything, and I think I have the opinion that you also touched the deleterious aspect of genetically modified organisms. It's only if we listen very carefully, we will see that you touched everything, and you touched on the good side. Now, regarding what Prof said, and the Chairman, following the simple principles of economics, availability of any product will determine its utilization, amongst other things. Now, if we allow the mechanized farmers who have all the means to do large-scale farming to turn every of our staple food into GMOs, what it means is that the availability of that, and of course the principle that is driving the economic argument for GMOs, is that it's going to be cheaper than the organics. In spite of all its deleterious effects, it's going to be cheaper. That's part of the strong point. Economically, it's going to be cheaper, and then of course it will be more resilient, and of course the yield is going to be much higher. But then, when it is rampantly available, everybody has the tendency to start consuming it. We as Nigerians do not have a health system to take care of the problem. I'm a medical doctor. I practiced medicine in this country for 35 years. My PhD is in ecology and environmental science. I'm a fellow of the World Health Organization in public health. So, talking about all of these issues, we cannot and we must not, like Prof said, since the people who are the ones that in the biosafety agency are the ones that should have their heads examined. And that is the truth. As a nation, we cannot give out or just sell our sovereignty on the principle, just for some, individuals to be able to light their pockets or to get international recognition or acceptance. We must, as scientists and concerned citizens of this nation, let the world know, let the people know. We're not saying that GMOs are completely bad. Professor Salau went to all of the very important developments that we have had that are very useful for us using genetic, biotechnology and bioengineering, which still remain. So what we are saying is, let us tell the government, policies should be made with the people's interest at heart. Our health systems are so fragile. We are battling with so many non-communicable diseases. Hypertension, we have not been able to deal with diabetes. We have a lot of issues with now mental illnesses are ravaging. So when we have this little amount of money to take care of our health, why must we go and look for more problems with our health so that we will now need more money? But the people who are making these GMOs are just happy to do it because, and Nigeria is a target because we are the most populous black nation in the whole world. Having a population of over 200 and something million people, everybody wants to bring their product here. And we must talk about the issue of incorporation of this into childhood, infant, immunization systems. It is just like we resisted. Living Science Foundation, with some of us, resisted the mandatory vaccination of Nigerians with COVID-19 vaccine. We resisted it. On the day that we were addressing our press conference, it was the same day the Federal House of Representatives was debating this. They passed the first reading, the second reading on the same day. And they were going to go to the third, and we said, no, we had our own people in the Federal House of Representatives, and we told them, stop this thing. It is not right. It's against your law. There must be public hearing before you can go to the third. And during the public hearing, we mobilized our own ourselves, and we were represented. And we told them, it is against science, and it's against the principles of public health that you make COVID-19 vaccine mandatory for Nigerians. What is the burden of the disease that we had at that time? Less than 4,000 people reported dead. In all the 3 or 4 years they were talking about COVID. When malaria kills how many in a day? Tuberculosis kills more than that in a day. So these are issues we are talking about prioritizing. In the principles of economics, let us prioritize. This is our problem. Our problems are many, and our resources are few. Then we must now target our resources to those our problems that we can address. And we don't start looking for newer problems, more devastating problems to help us because we want, some advantage from it. There is no development that does not come at a cost. We know that. Every development will come at a cost. Then we must do our cost-benefit analysis to be able to address our matters properly and safeguard the health of our people. Thank you very much. I just said that so that we can have our expertise. Pressmen, you told us that you will be leaving by 2. So we want pressmen. Oh, you want to say something? Thank you, sir. Please, pressmen, don't be patient with us for a while.
Foremost, I want to congratulate Professor Joshua for this 9th conference that is holding. We appreciate the effort over the years, and it's getting better every year. Thank you, keynote speaker. We don't expect less from our erudite scholar and Professor Bamidele Salam. Thank you, sir. I want to make a few points based on the discussions that have been ongoing and recommendations to the foundation. And this is stemming from the fact that the elders, and sincerely I want to apologize for making parables before elders, but the elders would say that you are not there when they were distributing, then you are now asking how they distribute. The Life Science Foundation has done very well in advocacy, no doubt. Sincerely, I remember a few years, year on year, and the Life Science Foundation would bring people from all walks of life onto our campus at Eden, and it's amazing. And what they are doing with the children, trying to bring their awareness. However, there are some things I think we need to be doing going forward. There is this passion with which our doctors hold, and these are real life issues that we are facing. But recently, my wife presented dinner, and I noticed a difference in the taste of the soup on the rice, and I was like, something happened. Say, what happened? That well, the tomatoes. Remember, there was a slight scarcity of tomatoes a few months back. The tomatoes were the local tomatoes gotten from Ole Market, not the Hausa kind that we used to consume. So I'm saying with all deference, and thank God our mothers are here, they can relate. Now, the issues being addressed by Papa technology regarding organoleptic appeal, pest management for the farmer, and all these, they are real issues. Yes, indeed, Life Science Foundation and other such stakeholders need to be looking at other areas of involvement, active involvement, in order not to turn this into another pity party where we just talk about those awful things. And the first one I want to draw our attention to is the policy development. By God's grace, I had the privilege of studying in Japan and working after obtaining my PhD. I was developing pesticides, safe pesticides that were exploiting the hormones of insects to ensure that you disrupt their metamorphosis, and these will not be deleterious to humans. And I do a lot of things. Now, those companies we are dealing with, not only do they have deep pockets, they are extremely powerful. Monsanto, which is the biggest GM company on earth, is in Nigeria. And they are doing some of things, like solving more of their products that were listed on there. And regardless of what happens, the whole world will leave us behind if we don't join the bandwagon. But however, we have the responsibility, just like our elder professor, we need to develop the wherewithal. How many of our laboratories have the ability to carry out simple training of our next generation of scientists that will develop homemade GM products? Because GM products are here to stay. So that, look, we will not depend on Monsanto in order to have our own GM product. All right. Now, the reason why the COVID issue was placed ahead in priority over malaria, just like our doctor observed, was that it was an issue of interest to those people that own the money, that have the money. And the health sector has been able to craft a system called One Health, whereby they are annexing and uniting those sectors that have to do with health. Now, we can do that for the environment. Making collaborations with such organizations. So I'll start by policy development. The gentleman on his way to Ibadan was quoting from a portion of our law. The question is, how many of us as professors are familiar with those laws that guard and guide the direction and impact of what we do, and even our doctors? So we need to ensure that we are aware of these things. I know for one that companies like Monsanto will not come here and introduce such products that were listed earlier by Professor Ojo without carrying out due diligence. The Pfizer situation was managed because Pfizer ensured that due diligence was done so that they don't violate some the WHO laws. Yes, ignorance is not an excuse. They were able to get away with it because you allowed it, doesn't, again, so you can't, I hope we understand. Some of those local laws need to be made in order to take care of these things that we are talking about. So how many of us are familiar with those laws? The policies under which you can introduce genetically modified crops into Nigeria. If there are loose ends, then it's us that will tie it. So that the data that is being used in order for such product registration needs to be perused by people like myself, Professor Salau, and say, well, these satisfy the requirements for Nigeria. When he was speaking earlier, he was talking about the situation with Mexico, and they said, no, under our own laws and rules, this is not acceptable. So policy development, all right? Policy development. Now, enforcement also. As a postgraduate student in Saga University, Japan, many of our projects that the university was able to get from companies looking to register their product had to go through the university system. So, for example, Migra, the and NAPTEP, and all these institutes that the university nation has set up in order to ensure the safety of biotechnology products. They are not working in tandem with universities, and they do not have the capacity to screen and monitor effectively these products. It's us in the ivory tower that will carry out these things. So enforcement, we need to know what these agencies are doing, where they need help, we can offer. Our postgraduate students can help to carry out some of these tests, and they can have the results, setting of standards. So I think that would be the next level of advocacy for us in life science and in the ascension of environmental sciences in Nigeria. Thank you very much.
Thank you, sir, for your very clear and educative contribution. We really appreciate that. The international section has almost ended because we have 2-3 powerful contributions. So we'll be proceeding forward to I think we have the prices now. I think we should proceed to that. Before I continue, I want to recognize the presence of the head of the Department of Electrical Electronics, Dr. Ilori. Thank you, sir, for gracing the occasion. Thank you. Yeah. Second. Also, we also recognize the presence of Reverend Bodon Lucy. Thank you for making our occasion. Thank you, and every other person that joined us later. We are trying to go to the award of prizes for the students and AF Oluwole prize for environment. So please, we will do the arrangement and give us 1 or 2 minutes to do the arrangement.
Thank you. 2 sets of prizes, one for the school children high school quiz. There was a workshop and whatever, and then the Professor EF award. The set of Professor is there, the speech is there, and the recipient is online. Professor Wajidi, I'm not go to this. So the plans have just come. If you are giving Professor Salawi's plaque and all those things, I will do this. But let's attend to the children first, and then to be here to. So I call on Mrs.
Good afternoon, everyone, once again, and thank you for your time. The students from various schools earlier today partook in a quiz competitions, and I must say that they came prepared. They all did excellently well. The first position from the quiz competition goes to Ife Anglican Grammar School with 31 points. Ife Anglican Grammar School with 31 points. The second position goes to OAU International School with 30 points. And the third position goes to Moremi High School with 25 points. So we'll be presenting their awards to them down.
The chairman of the advisors, Reverend NCEH, to kindly help us with the presentation. Thank you, sir.
So we're taking it from the third position, and that goes to Moremi High School. Moremi High School, please step forward.
Yeah, we'll make them together. Everybody? Yeah.
Thank you very much. Second position goes to OAU International School. OAU International School.
Everybody okay? All right. Good. Good. Good.
First position goes to Ife Anglican Grammar School. Anglican Grammar School.
Okay, everybody. Smile, smile, look at the camera. Hello, hey lady.
The other students can come.
Sorry, apologies.
All of them.
So like the banner would this.
Correct. You should move to the other side.
It won't come back. There's a media at the back there.
Oh, teacher.
Still try that much. So don't worry. I can't see your face. You can move on. If you move further up, no, I can't even get them.
Raise your plaque.
Okay. Please hold on. Please find a certificate. I don't need to do what I need to. Have they been?
Sorry, sir. I just like bang pass one. Okay, okay.
Thank you. And so please let's look at the next award. The next award. This is that.
Please, there is no sound here. We are muted, please. Is anybody here? Technical, please. Omute also. Hello, technical. Please help us to unmute this. We can't hear anything from our end. No sound, please. Please unmute this, please.
You can't say anything. Wow.